All right, my BC kids, here comes section 10.3. This one's called the nth term test for divergence. This particular test is best used just to check for divergence versus other tests that we've seen that check for convergence or divergence. So this one's just basically better for divergent situations. And here's what it says. I've got this sum and it converges. If the sum converges, then I know that the limit has to equal 0. But the opposite is not true. I think it's called a converse when they do this. If the limit equals 0, it does not mean that the sum converges. So it may either converge or diverge. Which means that really we call it inconclusive. Cool word, inconclusive. So in the story of our journey here, we can see that sometimes if I think about limits, sometimes like certain situations we know exactly what's going to happen, but sometimes it's going to be inconclusive and we have to try a different test. So in other words, the nth term test wouldn't be good for this situation because I wouldn't know if it converges or diverges. But maybe the situation might have another test that would apply, like the geometric series test or something like that. So we'll see that as examples come up with what we're studying today. So here's what the nth term test says for divergence. If the limit equals anything other than 0, then I know that the sum of my a sub n diverges. If the limit comes out to be anything other than 0, then I'm going to have a diverging situation. So this is a whole lot. Keep in your wheelhouse the horizontal asymptotes and things like that, because that's really what you're looking for. Remember, limits as I go towards infinity is kind of like evaluating where the horizontal asymptotes would be. All right, so here's the examples. Use the nth term test to make a conclusion about divergence for each series. In other words, does it converge or diverge? But they want me to specifically use the nth term test. Well, the nth term test says take the limit as n approaches infinity for your sum equation. So the limit as n approaches infinity of 3n cubed plus 1 over 5n cubed minus 2n squared plus 1. This one's a whole lot of a horizontal asymptote type of thing, right? If I look at this, powers are the same, so I take their coefficients, I equals 3/5. That's going to be what my limit is, and so that is clearly not 0, and I know if it's not 0, then I know that it diverges. So I know that, therefore, diverges. And we need to get used to saying which test we're using, so I'm going to literally say that in here. So it diverges by the nth term test. There's going to be a whole lot of different tests that we're going to use for checking for convergence and divergence, so we want to make sure that we're clear on which test it is. Okay, number 2. This one you might remember looks like a geometric series test from the last section, 10.2, and that's true, but remember they're asking us by directions to use this nth term test, so we're going to try it via limits and see what we think. Now if I put in infinity in here, I have 1/2 to infinity. Well, 1 to infinity is 1, but 2 to infinity keeps growing and growing and growing and growing. So that means I end up with a fraction that's 1 on top and a big number on the bottom, which means that this is 0. 0 times 3 is still 0. So there's 0, right? That one is equal to 0. That's one of those inconclusive situations using the nth term test. So it's inconclusive, I should say, by the nth term test. But we know that actually that looks like a geometric series, and I can tell whether it converges or diverges based on the R value, the common ratio. My common ratio is the 1/2. The absolute value of 1/2 is less than 1, and therefore I know that it converges by the geometric series test. So it was inconclusive by the nth term test because my limit came out to be 0, but I have the setup here for a geometric series knowing that 1/2 is my R value, and therefore I know it's going to converge by the geometric series test. Number 3. Number 3 says, okay, well, I've got 1 over n. This guy's a special one. He's actually got a special name. He's called the harmonic series. But if I do the same thing I've done with the others, following the directions, they want me to say, what's the limit as n approaches infinity for 1 over n? Well, again, 1 over a very large number is 0. That comes out inconclusive by the nth term test. But in a future section, you're going to learn that this is called the harmonic series, and it actually diverges. Now, you don't know that yet, so you wouldn't have a test that you could use to be able to say that. But when we get to the section that talks about p-series, what's called a p-series, it'll make more sense. So for now, just trust me, it's a diverging harmonic series. Number 4 requires... See, I've got these crazy powers. It requires me to play some algebra games first. So I'm going to take this thing and I'm going to rewrite it, and I'm going to see if this makes sense to you. I'm going to break apart the numerator to be 2 to the n times 2 to the second. I'm going to stop there for just a second because, does that make sense? What are you supposed to do when you have like bases with these powers? You're supposed to add them, right? Well, that takes me here. So what I just did was I broke apart these powers that are in an addition form and wrote them as their previous form of 2 to the n and 2 to the second. So they're one and the same. It's just maybe not something you might have thought about doing. I'm going to do the same to the bottom. 2 to the n times 2 to the third, and then a plus 1 at the end. And you know why you did that? Here's why. Because these 2 to the n's, they cancel each other out. And now I don't even have an infinity to substitute in here. My answer is going to be 2 squared is 4. 2 to the third is 8 plus 1 more is 9. 4 over 9 is not 0, and therefore I know it diverges by the nth term test. So sometimes you have to play some algebraic manipulation games to make this whole thing work. All right, last example is this guy here. Again, they asked me to use the nth term test, so I'm going to turn it into a limit going to infinity, e to the 4n over 3n. All right, this numerator is an exponential function, e to a power. So it's going to keep increasing, 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 increasing as I go towards infinity. So this guy is going to be an infinity. And 3 times infinity is infinity. Well, interestingly enough, you've got infinity over infinity. Does that ring a bell? And it should. If you think about L'Hopital, L'Ho, as we call him, we can apply L'Hopital's rule, L'Ho, which means that then I can change this and I can make it the limit, and that's because it's infinity over infinity. If I take the derivative of the numerator, I am 4e to the 4n. Derivative of the denominator is a 3. That gives me a 4e to the 4n, which is infinity over 3, or infinity. And since it's not 0, I know it diverges. It can be anything else, it just can't be 0. So diverges by the nth term test. And that is it for the notes for this section. So let's try a couple of problems. We're just going to do 3. There's actually, I think, only 9 or so to begin with. But the first one I want to do is number 4. Number 4. E to the n plus 1 over pi to the n. This one, they tell me in the directions, for each of the following series, determine the convergence or divergence of the given series and state the reasoning behind your answer. So they did not tell me which method to use. So sometimes you might use the nth term test, and sometimes you might use something you've learned in a previous section like the geometric series thing. So the first thing that I'm going to do is break this up. I have n equals 1 to infinity, e to the n times e to the first over pi to the n. And you'd see you've got two pieces that are both being raised to the nth power. That reminds me of a geometric series. So this is going to be n equals 1 to infinity, and I'm going to have my pieces being raised to the nth power as an e over a pi. That takes care of these, but I still have an e to the first. That's going to be my beginning a value. All right, so I have this set up as a geometric series. I can test for convergence using that. My r is e over pi, right, inside the parentheses. E is 2.718, pi is 3.14, 2 over 3 is less than 1, and therefore I know it converges. It's a converges by the geometric series test. Did it ask me what it converges to? And the answer is no, it didn't. I could certainly figure that out, and just as a reminder, remember it's going to be the first term, a r to the k, divided by 1 minus r. If you were, I actually did the workout for it. Not that you had to do this because it didn't ask for it, but if you got crazy and wanted to try it, it is e squared over pi minus e. Take the first term divided by 1 minus r, and you end up with that value. Okay, they just asked, does it converge or diverge? And so we already figured that out. So number 4 was the first one. Number 5 is kind of an intuitive, weird second one that I wanted to look at. Number 5, I'm going to do the same thing and break up that denominator like we've done with others. N equals 1 to infinity. This is 7 to the n plus 1. I can't break that up because of the plus sign that's there, but the bottom I can. This is 7 to the n times 7 to the first. So I want to figure out what the value of this would be. And it's kind of more of if I set the limit up, let me do the limit. Limit as n approaches infinity. This one, I can't break it apart like I did with this because of the plus sign. So I can't separate these two things to be able to create an r value like I did back in number 4. So this one I've just got to go up straight up with the limit. 7 to the n plus 1 over 7 to the n times 7 to the first. And here's where it gets more intuitive than algebraic. We are such algebra people, like that we just plug it in and we want to know exactly what the answer is. This is not that. This is a limit. So it's about what the y values are approaching, not necessarily what they equal. And so here's what I'm going to propose to you. If I take this 7 to the first away, how would these two compare, 7 to the n plus 1 versus 7 to the n, when I put an infinity in there? So 7 to the infinity plus 1 more versus 7 to infinity. How much of a difference is there between those two things limit-wise when I'm thinking about what the y values approach? Do I care if I'm at a huge number and I add 1 to it? It doesn't make a difference. So what happens is, in a weird way, these cancel each other out. And so what I'm left with for this is just 1 over 7. I know that's kind of an odd thing, but again, it's because it's a limit. And so if I look at this, 1 over 7 is not 0, and therefore I know it diverges by the nth term test. All right, here's the last one I want to do. It's number 8. Number 8. This one says, the nth term test can be used to determine divergence for which of the following series? Okay, nth term test, take the limit. N approaches infinity. of the ln of n minus 1 over n. Well, this is a fraction that I actually can break up because it's got a single monomial denominator, so I'm allowed to break these into pieces. It might make it a little easier for you to think about its convergence or divergence. Ln of n over n minus 1 over n. Or the limit as n approaches infinity of the ln of 1 minus 0. Oh, maybe I'll leave it as a 1 over n for now. Okay, so I have, if I look at this and put it in infinity, that's where I was getting this to be a 0. So this would be, the limit as n approaches infinity. Actually, I don't even really, well, if I plug in the infinity, I'm going to do a substitution. It's just going to be now the ln of 1 minus 1 over infinity is 1 minus 0. So it's the ln of 1, which is 0. And so therefore, this is one of those by the nth term test that's inconclusive. Now notice they didn't say use a different test. They're totally just talking about the nth term test. The nth term test can be used to determine divergence for which of these? Not for this guy, because he comes out to be a limit of 0, which is my inconclusive piece. All right, let's go to the second guy. The limit as n approaches infinity for 3n minus 2n squared over 5n squared. And I can see this is like a horizontal asymptote guy. So it's going to be just what these coefficients are, or negative 2/5, because those powers are the same. Well, negative 2/5 is not 0, and therefore it diverges by the nth term test. So there you go. You know that one works. Then I come down to number 3. Now it says to use the nth term test on this, although I can, well, we'll talk about the geometric series test in a second. They said use the nth term test. We're going to do it. Limit as n approaches infinity for 3 times 5/4 to the nth power. If I take 5/4 and raise it to the nth power, that's a growing function, right? The 5/4 is 1.25. If I take the powers of that, it keeps growing, 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 growing. Times 3 makes it grow just all the more. So this one is going to infinity, and if it goes to infinity, that's also not 0, so that means that this guy diverges as well. Now you might have been able to just check that out right off the bat, because see how it's in a geometric form? If it's in a geometric form, my r is 5/4. And if r is 5/4, it's greater than 1, and I know that it diverges by the geometric series test. So it's kind of one way or another, but since they said in the directions use the nth term test, that's what we did. That means that my answer is B. 2 and 3 are diverging by the nth term test. There you go. All right, I will be back again with section 10.4. Otherwise, if you've got any questions, shoot me an email, and I'll see you in class.